This question is for regular batch students in workbook 44 question. For GATE ECE students, question number 38. I am writing the question here. The force on a the force on a point charge plus Q kept at a distance d from the surface of an infinite grounded metal plate. That means conductor surface, that is in a medium of permittivity epsilon is. That is the question. Okay. Now let us solve that one. Actually, what that person is saying, there is one grounded metal plate, that means conductor plate, like this. This is the symbol of grounded. So let us assume that this is a plate actually. From front it looks like a line. Let us assume that it is at z is equal to 0 height. Wherever it is there, that is 0 height. Now plus q charge is there here. Plus q charge at d height. That means z is equal to d height. It is so it is d. Now point wise it is on z axis. If you take this as a z axis, then it is at the location. It is at the location 0, 0, b, because on z axis x value is 0 and y value is 0, but height is d here. So dear students, this is actually d distance. Now this is the original diagram. You want force on this. I told you you can't find the force because on this surface there on this surface there comes the negative charge. Because of this negative charge is induced. You don't know the location of that. Now what is the force on this q charge? This negative charge attracts that one. That means the force on this q charge is towards the conductor plate, because this negative charge attracts that one. So now let us draw the equivalent diagram. So equivalent diagram is you wherever conductor surface is there, I will remove this so that this is z0, this is z is equal to d height. So wherever conductor surface is there, you remove that, simply put one line there. So z is equal to 0. Then at a d height here plus q charge is there. That means location is 0, 0, d. Then again bottom side at d height here minus q, that is image charge at 0, 0 minus d location it should be there. Now actually that fellow wants force on this. That means this is force location. So R12 bar is equal to, you have to find force on this, that is F12 bar. So let us say this is 0.2. Now this is 0.1. You want force on this, so that is 0.2. So R12 bar is equal to, force is required here. So that location minus other charge location is 0, 0 minus d. So this is 0 minus 0 x, 0 minus 0 y, d minus of minus d is 2d az is 1. So what is modulus of R12? Root of 2d whole square, that is equal to 2d. Now what is F12 bar? So Q1 Q2 divided by 4 pi epsilon R12 bar divided by modulus of R12 whole cube. So here Q1 is plus Q charge, that is plus Q, and Q2 is minus Q charge, this one, and divided by 4 pi epsilon, and R12 bar is 2d az divided by, that is 2d whole cube. So that is equal to 1 by this is minus comes, so minus q square, then 2d cancel. So here 4 d square is there, 4 into 4 16. So 16 into pi into epsilon into d square. Then this one is az. So you can write like this. Magnitude means only magnitude should be there, but sign should not be there. So q square by 16 pi epsilon d square. Then that minus you send here, that is minus az. That means force on this is az means upwards, minus az means downwards. That is minus az. That is correct now. Mathematics is saying force on this charge is downwards. The concept also says same thing. Here positive charge is there, and this negative charge is induced. This negative charge pulls that positive charge downside. So in answers, no, like this mathematical equation is not given. Statement form is given. So this is the magnitude of the force, and this is direction is downwards. The conductor plate here downwards, no. So minus az means it is downwards. So what is the answer? Now force on plus q is q square by 16 pi epsilon d square Newton, and direction is towards the conductor, or otherwise metal plate, towards the conductor plate. So this is the answer to this question, students. Actually, for explaining it is taking so much time now that no need to do this much. Simply here itself now, 0.2 is 0,0d, 0.1 is 0,0 minus d, and then directly you come to this step. No need to write so many steps. But for explanation I am doing in detail. But in examination directly you start with this. So first charge is plus q, second charge is minus q divided by 4 pi epsilon. Then R12 bar is this one minus this one. No need to put the diagrams and all. You know that anyway, if this is at 0,0d distance, automatically it is at 0,0 minus d distance. Directly you come to this step, then you will get this one. You can tick mark that. Okay. Now, one more image theory question. So this is the question. A point charge q is situated at a distance d from the center of a grounded conducting sphere of radius r. So I am drawing the diagram here. For example, this is a sphere I will take. So it is grounded conducting sphere means it is grounded here. It is a spherical surface. Then what is the radius of this actually? The radius is r. Maybe this side or the inside radius is capital R. It is given here. Now a point charge q is situated at a distance d from the center. This is the center. From a distance d from the center of a grounded conducting sphere of radius r. So I am putting that here at this distance q I am putting. Now this distance is actually is saying d distance is there, d. So d is the distance. How do I know this is outside the sphere? It is given this d distance is greater than r. So this is r, this is outside. Now this is the question. Okay. So this is a conducting sphere. So this is conductor spherical surface actually, this one. Okay. So this is conductor spherical surface, grounded this one. So now this charge is nearby this conductor surface. Now you have to use image theory concept. Which concept? Image theory concept. I will reduce the size of the diagram so that here is q. So this distance is d. This is the diagram, original diagram. Now if any charge is nearby the conductor surface, then you have to draw the equivalent diagram. So what is the equivalent charge diagram. Equivalent charge diagram. Students, put the charge itself. For example, we will go like this. What is this? Spherical conductor surface. Now in equivalent diagram, there should not be a conductor surface. No. Simply imaginary conductor surface should be there. I am drawing like this. Radius how much? R radius. What is the material? No material, it is imaginary. Because in equivalent diagram, conductor surface is removed. Then what is the potential? How much potential it should have? Zero potential. Anywhere potential should be zero. Now, what is the charge? Charge is charge is Q. How much distance it is kept? Answer, from the center, it should be at a d distance. Okay. Now, do you think you got 0 volt here? No. Then what to do to get 0 volt? You have to put image charge of this one. Now let us read other half of the question. The value of the image charge is Q1. He has given name of that image charge as Q1, but he did not give equation of that. He is asking the equation of that. Image charge is Q1 at a distance B from the center. That means from the center, no, it is at a distance, that image charge is Q1. It is at B distance from the center, like this. Now you will ask me the question, how do you know this B is inside this sphere? Yes, common sense. I want here 0 volt. That means I want here 0 volt. To get 0 volt here, definitely this side positive charge is there, means this side negative charge should be there. That is the key point. So conclusion is, if positive charge is outside the sphere, then image charge should be inside the sphere. For example, if this positive charge is inside the sphere, then image charge should be outside the sphere in such a way on the conductor surface, wherever conductor surface is there, you have to imagine one spherical surface. On that you should get 0 volt. Now, this Q1 charge, no, from center at B distance, no, you can imagine anywhere on this circle like this. But we have to calculate the potentials on these surfaces and then equate that potential 0. So to find potentials, we need distances. The distances can be easily calculated if you imagine the points on these surfaces. Anyway, once again I will repeat. This is conductor surface. Shape is a sphere. Now in equivalent diagram, you imagine a spherical surface and then take the original charge and then image charge. He has given image charge name as Q1. Then where it is kept? From the center, it is at B distance. I told you, here you have to adjust the Q1 value and B value in such a way you get 0 volt on the surface. Now, did you get 0 volt here? No, because you have to find Q1 value, B value in such a way you get 0 volt here. Now, you have to find B equation and Q1 equation. So, how many unknowns are there? 2 unknowns. In mathematics, to find 2 unknowns, you need 2 equations. So, that is why I am selecting one location on this sphere, second location on this sphere, and for these locations I know the distances also easily. That is why I selected those locations here. Now I am calling this as location A. So here potential is VA, I am calling this as location B. Here potential is VB, I am calling. Now do you think those potentials are 0? No. Let us find the potentials. Now potential formula is Q divided by 4 pi epsilon R. Now total potential at A location is equal to Potential at this location due to discharge is Q divided by 4 pi epsilon. Distance from charge location to potential location is D minus of R. This is D minus R. Now plus potential at this location due to discharge is Q1 divided by 4 pi epsilon. Distance from charge location to potential location is total is R minus B. So it is R minus B you got. So what is the potential at B location here? Potential at this location due to discharge is Q divided by 4 pi epsilon. Distance from here to here is D plus R. Then what is the potential at this location due to discharge? That is Q1 divided by 4 pi epsilon. So distance from here to here is R plus D it is. Now what to do? Find Q1 comma B values in such a way VA must become 0 and VB must become 0 because we need here potential 0. So that is the imaginary concept. Now you equate VA 0. So if you equate VA 0 and get this side, now you get here Q1 is equal to, from that you get Q1 is equal to, otherwise I will do one thing. From this Q1 divided by Q is equal to Q1 divided by Q. It goes that side. So you get minus of R minus B divided by, it goes that side, na? D minus R. Okay, let us say this is equation 1. Similarly, if you get VB0, you get Q1 divided by Q is equal to minus of equal to, so it goes there. So R plus B divided by D plus R you get. So equation 2. Now both are equal. So equation 1 is equal to 2. I will solve there. So now both are equal. So you cannot use the concept of parallel plane, student. This surface is different. This is standard question. You have to remember this answer. Anyway, I will write the step here. Next step I will write there. That implies now minus of R minus B divided by D minus R is equal to minus of R plus B divided by D plus R. Now you cross multiply them so that you get R minus B into D plus R is equal to D minus R into R plus B. So this is equal to R into D, next plus R square minus B into D minus B into R. So dr plus dB, then minus R square, then minus R into B. Let us see some quantities going to cancel. Some are going to cancel here. You see what is here. R square comes this side. Okay, I will do one thing. I will get them on side. So this RD, DR, this cancel. Next, anything else? Small b into capital R, small b into capital R. This also cancels. Now this R square comes this side, so 2R square is equal to, this goes this side, 2BD. From this 2 to cancel, you get B is equal to R square by D. So this you have to remember. Now to get 0 volt here on this surface, B value is calculated from this radius square divided by this distance. Now let us say this is equation number 3. If you put 3 in any one of the equation, you get q dash value also. For example, put equation 3 in equation 1. Then what you get, q 1 is equal to minus of r minus b is r square by d divided by denominator there is no b, so d minus r into q. So this value is equal to something is cancelled now here. D comes here, r also comes here, so r by d outside, so minus r by d. Okay, r common, d common. Then here comes d minus r cancel. Okay, this much only you get q. So my dear students, where can I write? I will write here. So that implies q1 is equal to minus r by d into q. This is the q1 equation. So this formula you have to remember, dear students. This is standard question. Anywhere q charge is there near the r radius sphere, then image charge value equation is this one. Because image charge, if it is positive, then image charge is opposite of that one. Then capital R, that is radius of the sphere, divided by d. Then this is r square by d. This. Now what is the conclusion? If you calculate b using this formula, if you calculate q1 using this formula and put q1 at here at this distance, automatically you get here 0 volt. So that is the solution. Okay. So you have to remember this one and this one. That is standard question actually. Okay students, now if you get this question, you should not solve this one. Directly you have to remember this and this equation. Okay. So dear students, now let us discuss electric field and electric field intensity. Okay. Basically field means some volume. In this volume, if you put a point charge, then in that volume electric effect is present because electric source is there. For example, if bulb is there, then in some volume light effect will be there. That you can call that as a light field. In some volume, if you put magnet, then some other magnet will be attracted or repelled in that volume. So that is called magnetic field. Now electric field is a volume, otherwise some space, is a volume where electric effect is present. Now if there is electric field, what quantities you can measure in that? You can measure potential, you can measure electric flux density, you can measure electric field intensity, you can measure electric energy, you can measure electric energy density, you can measure force on any charge in the electric field, you can measure so many things. Now among them, one of the physical quantity is electric field intensity. So now electric field intensity we are going to measure in the electric field. So electric field intensity, okay, electric field intensity. There is a definition, I will write the definition. Electric field intensity is defined as force vector on unit positive test charge. That means this charge, unit positive charge is kept for testing purpose. Unit positive test charge. Actually, that is 1 coulomb charge. Okay. Now we are putting one symbol E12 bar. The meaning is electric field intensity. Electric field intensity at point 2. This one at point 2, where plus 1 coulomb charge is present. That means at point 2, 1 coulomb is present. Actually, if you want electric field intensity at point 2, then you have to put 1 coulomb charge at point 2. Okay, electric field intensity at point 2 due to Q charge at point 1. That means meaning is, if there is a Q charge source at point 1 location, then it generates electric field in some volume. In that volume at point 2 location, if you put 1 coulomb, then you can measure force on that. That is called electric field intensity. I am drawing a diagram here. For example, if I put Q charge here, that is charge source. Wherever you put this, I am calling it as a point 1. Now this charge source produces the electric effect in some volume. Anyway, this charge value is finite. That is why the electric effect also present only up to finite volume. So for example, in this volume, electric effect is there. How do you know electric effect is there in this volume? If you put plus 1 coulomb test charge, it cannot attract because this 1 coulomb is outside this electric field. So if you put 1 coulomb here, assume this is also positive charge, then this positive charge repels this one. Why it is repelling? Because this positive charge applies repelling force on this. This charge is present in the electric field. Now, how much force is applied by this charge on this test charge? For example, this test charge is at point 2 location. Then that is called as electric field intensity at point 2 due to Q charge at point 1. Once again I am repeating. If I put Q charge, then around this in some volume electric effect is there. Then in that electric field, if I put plus 1 coulomb test charge, then I assume this is also positive, this is also positive. This charge repels that. Why it is repelling? Because there is a force on this due to this one. How much force is applied on this due to Q charge? That is called electric field intensity. Now here I call this as we are finding electric field intensity here, E12 bar at this location, and this is test charge actually. Now here somewhere origin will be there. Where is the origin? Somewhere it will be there, because always we give the location of this as point 1, location of this as point 2 with respect to some origin. Origin is here. Let us assume that origin is here. So we are assuming origin is present here. Okay, dear students. Now, if you see, if I write the positional vector OP1 bar, this is position vector of point 1. What is this? OP2 positional vector of point 2. Okay. Now, what is this actually? Similar to previous force case we have discussed in Coulomb force law, same discussion. But in Coulomb force law, here in place of in Coulomb force law, Q1 charge was there. Now here Q charge is there. In Coulomb force law, here Q2 charge was there. Now here plus 1 Coulomb charge is there. So, dear friends, now here R12 bar. What is this R12 bar? Is equal to zero point 0.2 minus 0.1. Now, what is this one? This one, A12 bar, A12 bar, unit vector. Actually, I told you this is written as AR12 bar, but suffix name is lengthy. That is why we have kept short name as A12 bar simply. Now, I am telling you, you see this one carefully. What is, if I put Q2 charge here, then F12 bar is equal to Q1 Q2 divided by 4 pi epsilon A12 bar divided by mod R12 whole square Newton. Now what we do? What is electric field intensity? E12 bar is equal to, what is that definition? Is defined as force on plus 1 coulomb. That means Q2 is replaced with 1 coulomb due to Q charge at point 1 divided by 4 pi epsilon A12 bar divided by modulus of R12 whole square. So now if you see the units now, this Q into 1 is actually 1 only. Now this is the formula. If you see the units, Q is coulomb, so this is coulomb divided by epsilon. 4 pi no units, epsilon is actually farad per meter, and A12 no units, so meter square. Now that is nothing but coulomb by farad into 1 by meter. So you students know that Q is equal to CV, V is equal to Q by C. So coulomb by farad is actually volt. So that is volt per meter unit actually. So the unit is volt per meter. Other unit is what? Let us see. Other unit of electric field intensity. For example, students, what is E12 bar? I have written here. Electric field intensity at point 2 where 1 coulomb is present due to Q charge at point 1. Now, for example, let us assume that there is no test charge. I mean, test charge is not available to us. हमको टेस्ट चार्ज अवेलेबल नहीं है मान लीजिए, देन हम लोग क्या करेंगे, इधर Q2 चार्ज रखेंगे, Q2 चार्ज. Then F12 bar is equal to force on Q2 charge due to Q1. In place of Q1, Q is there, so divided by 4 pi epsilon and A12 bar divided by modulus of R12 whole square, students. Now actually this is Newton's. Now what we do, how much force is there on unit charge means divide with Q2. This is force on Q2 unit charge. Force on 1 coulomb means divide with Q2. So then you get Q by 4 pi epsilon A12 bar divided by modulus of R12 whole square, students. Now what is this formula? This is nothing but E12 bar. So ultimately F12 bar by Q2 is equal to E12 bar. From this now, electric field unit is Newton per coulomb. So 2 units are there, Newton per coulomb, otherwise volt per meter. Now from this we get one more formula. F12 bar is equal to Q2 into E12 bar. This formula I will write in the note. So dear students, what is this? If E12 is electric field intensity at point 2 on plus 1 coulomb charge, then if I put here electric field intensity is E12 bar, if I put Q2 charge at point 2 location, how much force is present on that? Q2 into E12 bar. That is also one formula. So after listening this much, I am writing the formula here in the note. You see here. So E12 bar is equal to, now I will write in the sequence what to remember. Here E12 bar is equal to, I will write here, okay. So the E12 bar is equal to Q divided by 4 pi epsilon and A12 bar divided by modulus of R12 whole square, that is equal to Q divided by 4 pi epsilon, and this one is R12 bar divided by modulus of R12 whole cube, dear students. Okay, now what is the unit? I told you volt per meter, or otherwise Newton per coulomb. 2 units are there, so you remember this formula, dear students. Okay, this is electric field due to point charge. In examination, if they ask you electric field intensity due to point charges, always you have to use this formula. Now what is R12 bar here? So R12 bar is equal to 0.2 minus 0.1. So here 0.2 is we are finding electric field intensity. So that is called field point. That means the point where we find the electric field intensity, minus 0.1 is source point. So charge source point, that is simply source point you write. So that means in the question, wherever you want electric field intensity, from that location you have to subtract other location. So this is R12 bar. So how to find electric field intensity due to point charge? If there is a positive charge, put positive charge here. If there is a negative charge, then put negative value here. Then find R12 bar. Write R12 bar here. Then divided by R12 bar magnitude whole cube. This is the formula. Now, actually, E21 bar means minus of E12 bar. No need to discuss that. Now, dear students, actually, if you want, you can write here A12 bar is equal to R12 bar divided by modulus of R12. So, this is a unit vector in R12 bar direction. So this is what is this actually? Unit vector in R12 bar direction. Unit vector in R12 bar direction. Okay, R12 bar is distance vector from point 1 to point 2 actually. Okay, dear students. Now one more point. E is proportional to Q. So E bar is linear. E bar is linear with respect to charge source. That means if two or more sources are there, then if you want electric field intensity, find electric field intensity due to single source, then add, you get total electric field intensity. So I told you already, in our subject all formulas are linear. Okay, dear friends. Now, after completing this, we have to discuss the formulas of electric field intensity due to line charge, surface charge, volume charge. We have to discuss general formulas. So before that, I will tell you one thing, student. If Q charge is there here, that is big value, then here also more electric field is there. We call it as E12 bar. Then formula is this one. For example, if I put 0 charge, then no charge source, electric field intensity also 0. Then if I put a dq charge, that means very small charge, then electric field intensity here is dE12 bar. Then here dE12 bar is equal to dq. So this is the formula. What I am telling you, 0 charge means 0 electric field. Very high charge means high electric field. dq charge, differential charge means differential electric field. Like that. So this is the formula to extend this point charge formula for line charge, surface charge, volume charge. So now I am writing here. If it is in the box means you have to remember that one box. So now actually I want to write one note here. Electric field due to line charge, point charge, line charge, surface charge, volume charge. We have to write the general formulas. Okay. Now here I am writing note here. First one, if dq charge is there, let us say at point 1 location, then at point 2 location let us say plus 1 coulomb charge is there, then here differential electric field intensity at point 2 due to Q charge, dq charge at point 1 is dE12 bar. So this is actually R12 bar. Now the formula is, I told you, you put D here, then here also you have to put D here. So dE12 bar is equal to dq divided by 4 by epsilon modulus of R12 whole square A12 bar. Of course, I will not write again and again. Any time if you write unit vector here, then whole square will be there. Then any time if you write vector here, then whole cube will be there. No need to discuss that again and again. Then every time definition of R12 bar is the field point minus source point. You can remember this also. Wherever you want electric field, then that location minus other charge location. So here dE12 bar means is differential, that means small, differential electric field intensity, differential electric field intensity at point 2, there 1 coulomb charge is there due to dq charge at point 1 location. So this is the formula. Now what happens? Now let us write the electric field intensity due to line charge. Let us say if there is long line, on this everywhere charge is there like this. Now what is the total length of this line? Let us say total length is L. L is total length. Okay. What is the line charge density on this? So line charge density is rho L coulomb per meter. Line charge density is present here. So line charge density, rho L, already you know that. So here rho L is line charge density. Line charge density this is. Now already you know all the things now. If you take dl length here, dl scalar student, actually students, for example, if dl bar is equal to dx ax is there, then dl means only scalar, scalar means dx actually, like that you have to take. Okay. Here, now here how much charge is there in small length? Let us say dq charge is there. Now already we have discussed that dq is equal to rho L into dl. Why you are not taking a vector here? If you take vector, this also should become a vector, but charge is defined as a scalar. So you take magnitude. So now in small length, small charge is there, and this is coulomb per meter into meter gives coulomb. Okay, in small length, small charge is there. Now what is the dE12 equation? This is the equation. So this one. So dE12 bar. Okay. Now let us say here there is a point 2. Now wherever you select small length, that is called point 1. Wherever you select small length, there dq charge is there, that is called as point 1. Okay. Now you want electric field intensity here, then E12 bar here, then draw the R12 bar here. This is R12 bar. R12 bar is nothing but 0.2 minus 0.1. What is 0.1? Wherever small charge is there, that is 0.1 actually. Okay. Now what is the formula of that one? This is the formula. So dE12 bar is equal to dE12 bar is equal to us write differential electric field intensity dE12 bar. Differential electric field intensity at point 2 due to dq charge at point 1 is dq divided by 4 pi epsilon A12 bar divided by modulus of R12 whole square. Now in place of dq you have to substitute this one. So du12 bar is equal to rho L dl 4 pi epsilon A12 bar divided by modulus of R12 whole square. Now total electric otherwise total E bar, you say total E bar is, you have to integrate this one, that is nothing but E12 bar is equal to integral rho L dl divided by 4 pi epsilon A12 bar by modulus of R12 whole square, and in place of A12 bar you can write R12 bar by modulus of R12, like that. So this is a general formula of electric field intensity due to a line charge. Third one, let us consider a big surface, and on that big surface let us select some ds volume. Then this where this location is selected at point 1. Now on this surface it is given everywhere charge is distributed like this. Charge is distributed. Okay. Now here rho s coulomb per meter square is actually surface charge density is present, surface charge density. Now if you want electric field intensity at point 2 location due to dq charge present at point 1, now this one is actually R12 bar, so this is here, you want electric field intensity here. Actually due to dq charge you will have du12 bar here, but if you want total electric field you have to integrate that one. Okay, now in this case how much dq is there? Answer rho s into ds. Already we have discussed this previously. So in small area small charge is present, coulomb per meter square multiplied with meter square, then you get coulomb. Now once again, what is the differential electric field intensity formula? So dE12 bar is equal to, and dq divided by 4 pi epsilon, this one only, where dq is equal to rho s into ds divided by 4 pi epsilon A12 bar divided by modulus of R12 whole square. Now ultimately students, if you want actually in every case I wrote the meaning of dE12 bar here. This is the dE12 bar meaning. Differential electric field intensity at point 2. Every time at point 2 location you have to put 1 coulomb test charge, and then dq due to dq charge present at point 1. Now total E bar is, so take 1 point charge here, then find electric field. Take 1 point charge here, find electric field. Then your total electric field is sum. You have to add, because electric field is linear. Add means integration. So total E bar is integration means how many integrals? Double integral. So double integral rho s ds divided by 4 pi epsilon and A12 bar divided by modulus of R12 whole square. If you want, you can write like this: double integral rho s ds r12 bar divided by 4 pi epsilon modulus of r12 whole cube you have to write. So here r12 bar means I wrote now already 0.2 minus 0.1. Once again, don't confuse. Some students confuse that, sir, ds is a vector. Then why are you not taking vector? Already told na, charge is scalar. And this is scalar, this is scalar. Scalar into scalar is scalar. If ds bar is there with you, equation is there with you, ds bar equation, then remove the direction, write only magnitude. Okay, dear students. Now, let us talk of volume charge density. There is very big volume. There is big volume. Now, in that big volume, you have selected a very small volume. How much volume you have selected? dV volume. At which location? 0.1 location. Then how much charge is there in this? dq charge is there. Now here at every location there is charge in the volume. Okay, at every location there is charge in this volume. Now they have given rho v coulomb per meter cube equation, that is volume charge density. What is this volume charge density? Now, for example, here 0.2 is there. 0.2 is there. This is called R12 bar. R12 bar. Now here you have to find the electric field intensity E12 bar. Now here dq is equal to rho v into dv. So dq is differential charge. Now what is d12 bar equation? So d12 bar is equal to dq divided by 4 pi epsilon a12 bar by modulus of r12 whole square. In place of dq, we will write rho v dv. Okay. Now total E bar, that means total electric field intensity at 0.2 due to volume charge is E12 bar is equal to triple integral rho v dv divided by 4 pi epsilon A12 bar divided by modulus of R12 whole square. Okay, so these are the four formulas. Due to point charge, one formula, and due to line charge, one formula, electric field intensity formula, and due to the surface charge, one formula, and due to the volume charge, one formula. So point charge is one type of source. Then in case of line charge, finite long line is there, infinity long line is also there. In examinations, every time you get only infinity long line questions, but we will solve finite long line question also. Similarly, in examination, you every time get infinite area surface only, but we will solve question of finite area surface as well as infinite area surface. Both we will solve. Okay. So let us solve one question. The question is, find E bar in all regions due to Q point charge located at origin. So actually, point charge questions are solved in spherical system. It is easy to solve point charge questions in spherical system because point looks like a sphere. So now let us take point 1 where point charge is kept. That point is actually origin. Now at point 2 we want electric field intensity. In spherical, which point represents all regions? I told you, general point in spherical coordinate system, that is r comma theta comma pi, and you want electric field intensity here. Now this is origin and this is r theta pi. Then what is the positional vector? In spherical system, origin is written like this. So r12 bar, you go and see the positional vector, don't forget. So that is simply RAR. So R12 bar, that is nothing but positional vector from origin to this one. R minus 0, theta minus theta, pi minus pi. So I told this is origin in spherical system. If you convert this to rectangular system, then that origin becomes 0, 0, 0, because in rectangular system x is equal to r sin theta cos pi, r0, so x0. Y is equal to r sin theta sin pi, where r0 here, so y0. Z is equal to r cos theta, r0, so z also 0. Now, due to point charge, electric field intensity is equal to, general formula is 4 pi epsilon r12 bar divided by modulus of r12 whole cube. Now, what is modulus of r12 here? That is equal to root of r square, that is equal to r. So q divided by 4 pi epsilon, and it is r divided by r cube. So ultimately we get q divided by 4 pi epsilon r square ar. So here, now this is the derivation. Actually, we don't want to learn even single derivation for examination. Only we need formulas. But after derivation, if I tell the formula, then we will understand it easily. Some derivations we skip because we have to save the time, and in less time we have to study more. And I will do many derivations. But you should not learn the derivation. No use. After derivation, I will be writing the note. You have to study that note. Now let us write a note here. First point, E bar at PR theta pi due to Q point charge at origin is E bar r comma theta comma pi is equal to Q divided by 4 pi epsilon r square ar cap. This is magnitude, this is direction. If you see the direction, if there is a Q charge here, then electric field direction is ar cap, means already we have studied. It is radially outward from the point charge, or otherwise from the origin. So that is why it is concluded that if there is a point charge that looks like a sphere, then ar cap is 90 degrees to spherical surface. That is why conclusion is electric field lines are always 90 degrees to the charge surface and go away from positive charge surface. Similarly, what is the E bar at PR comma theta comma pi due to minus Q point charge at origin is, if you put here minus Q and here minus Q comes, if there is plus Q, here plus Q, if there is minus Q, here also minus Q is there. So then electric field at r comma theta comma pi is equal to minus q divided by 4 pi epsilon r square ar cap. So q divided by 4 pi epsilon r square minus ar cap comes. So here it is minus q, and actually ar cap means away. I told you AR cap is in the direction of increasing R value, minus AR cap is in the direction of decreasing R value, or otherwise simply AR cap is outwards, opposite will be the minus AR cap. So no need to discuss minus AR cap. Here now I wrote magnitude. Magnitude means it is positive. And direction. Direction also has sign also, like this minus AR. So from these two, what is the conclusion? Electric field lines, for example, there is a surface here, a positive charge surface. Actually, that surface looks like a, let us say, this is the surface, and this positive charge is there. Then that surface looks like a line. Okay. Now then, there is another surface here. Negative charge is there, like this. Now, electric field lines start 90 degrees to the positive charge surface and end on the negative charge surface. That is also an experimental result. Experiment is also seen like that only, but mathematics also says same thing. Electric field lines are 90 degrees to the spherical surface and goes away and end on negative charge again at 90 degrees. So, like this. Electric field intensity. Maybe in next topics we will study electric flux and d bar also in same direction. We will study them. Okay, right students. Actually, now what is the statement? Electric field intensity vector is perpendicular to the positive charge surface in outward direction and perpendicular to the negative charge surface and inward direction. That is the statement. And these two also are in same direction. So, E bar, that means electric field intensity. Of course, or electric flux or D bar. Okay, E bar is 90 degrees, that means perpendicular. 90 degrees to positive charge surface in outward direction, comma 90 degrees to negative charge surface in inward direction. In inward direction. This statement is written here. Okay. This is actually 90 degrees. This angle, no? 90 degrees. Here also it is 90 degrees only. Okay. Just I am putting symbol, right angle symbol. This is 90 degrees. Next, fourth point is force on Q2 charge at point 2 due to E1 to bar. E1 to bar means you know, due to E1 to bar. What is E1 to bar? What is E1 to bar? E1 to bar is electric field intensity at point 2 where plus 1 coulomb charge is there due to Q charge at point 1. That is the meaning of E1 to bar. So now we'll read this one. Force on Q2 charge at point 2 due to E1 to bar is F12 bar is equal to Q2 into E12 bar. So simply we study this like this. If you put Q charge in the electric field intensity E bar, then what is the force on that? Answer Q into E. Like this, but it is written in detail. It is written. Okay. For example, Q charge is there at point 1, then plus 1 coulomb is there at point 2. Now here electric field intensity is E12 bar. So this is actually R12 bar vector, here distance vector. So this one is E12 bar vector. So now if you know E12 bar at this location due to Q charge at point 1, then now you take Q2 charge, assume this is Q2 charge. If I put Q2 charge here, then force on that is Q2 into E12 bar. Okay. So with these formulas, we can solve a few questions in the workbook. Now let us solve them. So here I am writing the question. So the question is question number 8 for regular students. For GATE students, that is question number 6. You see that question. So dear students, question number 8 for regular batch students, and for GATE students question number 6. I am writing the question here. So regular students question number 8, GATE in GATE workbook it is question number 6. Okay. A positive charge Q coulomb is located at, simply I am writing is at 003, and a negative charge of magnitude Q coulomb is at point B 00 minus 3. The electric field intensity at point C400 is in the direction of option A which is given. So very simple students. E12 bar due to point charge is simply I will write like this. E12 bar, already you know student, why to waste time? Electric field intensity due to point charge is Q divided by 4 pi epsilon R12 bar divided by modulus of R12 whole cube. This is electric field due to point charge. Now here Q charge is there and minus Q charge is there. Two charges are there. You want electric field here. So total E bar at point at C is E1 bar plus E2 bar. That means E1 bar means electric field due to first charge source. E2 bar means electric field due to second charge source. So now E bar at C400 due to plus Q at point A, that is 003 is, now answer, I am calling that as a E1 bar. I am assuming plus Q charge as a source 1. Now answer is plus q divided by, I told you if there is plus q, put plus q here in place of q. If there is minus q, put minus q there. Plus q divided by 4 pi epsilon. Actually, anytime, no, if medium type is not given, no, you put as it is like epsilon. But in answers, if you find epsilon not, no, then you also take like a medium and put epsilon not. It doesn't matter. Anytime medium is not given means that is generally air medium or otherwise free space. Now, what is R12 bar? R12 bar is nothing but field point minus source point. So here, okay, here I will write, actually no need to write now, that is direct, that is why. So R12 bar means field point. What is the field point? That is 400 minus plus Q charge is at this location, that is called source point. So field point minus source point, this one. Now you find this one, 4 minus 0 AX, so 4 AX, then 0 minus 0, 0 minus 3 means minus 3 AZ divided by, this is R12 bar. What is the mod of this? Root of 4 square, root of 3 square, root of 4 square plus 3 square, that is 5, so 5 cube. Similarly, E bar at say 400 due to minus q at point B, that is 0, 0, minus 3. Students, here negative charge is there, magnitude is q, that means minus q charge that is. Now once again, I am writing R12 bar here, that is point 2 is field point we want here, minus point 1 is source point, that is at 0, minus 3. Now E2 bar, that means electric field intensity at this location due to minus q charge. So minus q divided by 4 pi epsilon. Now this is 4 minus 0, 4 AX, 0 minus 0, 0 minus of minus 3 is plus 3 AZ divided by root of 4 square plus 3 square is 5, so 5 cube. So this is the electric field due to minus q charge source. So total E bar at C location is equal to E1 bar plus E2 bar, that is equal to, in both of them q by 4 pi epsilon 5 cube is common. So q by 4 pi epsilon 5 cube is common. So 4ax minus 3az, here minus is there. So minus 4ax minus 3az. So ultimately minus 6az q by 4 pi epsilon 5 cube. Actually, if you want the electric field equation, this is the electric field equation. But in the question only direction is asked. So E bar is in the negative z direction, minus az. Dear friends, there are two methods to solve this question. Another method is, you take this as a y-axis, this as a x-axis, this as minus z, this as a plus z. Here point A is at 0, 0, 3, positive z-axis. Then minus q charge is at point B, 0, 0, minus 3. Then electric field is required at point C, that is 4, 0, 0. Then find electric field here. Then electric field direction is like this. Then divide tangential and normal component. Similarly, electric field here due to this one is in this direction, like this it is, because electric field is towards minus q. Then again split that, then it will have two components. So some cancel, some add. Again you get same answer. But why I am not following this method here? Because in the engineering exams, always you get, in general, 3-dimension point. This method is easy if it is 2-dimension question, but we have to follow the methods which are applicable for all the cases. This is also confusing. You will not get electric field magnitude, you will get direction only. But this is very simple procedure. Actually, if I solve this question in exam, what I do, this question, directly I will be writing like this. You can see here, E bar is equal to electric field due to plus Q charge is Q by 4 pi epsilon. Then R12 bar means this is field point, this is source point. So 4 minus 0, 4ax, 0 minus 0, so 0 minus 3, minus 3az divided by 5 cube, plus electric field due to minus Q charge means minus Q divided by 4 pi epsilon. Then what do you say? Electric field is required here, so this is field point, this is source point, so 4 minus 0, 4ax, 0 minus 0, so 0 minus of minus 3, so plus 3az divided by this root is 5 cube, or no diagrams, nothing. So dear friends, I told you, any time in the points, now for example point A is given very complicated, now point A is minus 2, 1, 6 like this, and point B is given minus 2, 7, 20 like that. So in that case, similarly C point also given, all three values are there in this. Then in this case, no students, some insect it is, don't worry. So actually in that case, no students, drawing a diagram and that method is very difficult. So this method is very simple in that case. Actually, you understand, we are not giving locations to the point also here. Simply R12 means field point minus source point. We are not bothered about locations also. So this method is applicable everywhere. Okay. But anyway, if you are comfortable with other method, you don't worry. The purpose is you have to get the answer in less time. Okay. Actually, what we are doing now, we are following methods. In these methods, simply we give the location, like where is the source, give the source location and give the electric field location. Simply you subtract electric field, you subtract source location from electric field location, you get R12. Then question solution is over. Okay. Okay. Electric flux actually. Okay. This is symbol is psi. Electric flux. It is also called as displacement flux. Now, if you see the meaning, flux means flow, electric flux means flow. Flow means moving hand. Flow of electric effect. Flow of electric effect, student. Okay. Now, let us take case 1. Case 1. So dear friends, before going to case 1, I will explain you one thing. Everybody knows what is parallel plate capacitor. This is one conductor surface. What is the meaning of conductor? Conductor has atoms, and at least each conductor atom gives one free electron. Then that conductor atom becomes ion, which cannot move, and one free electron like this. So these free electrons can move. So that every conductor material has positive ions and electrons. Already I told you previously also. Now they can move these electrons, free electrons, but ions cannot move. And also this conductor surface is neutral. Now here I am taking one more conductor surface. And already I told you regarding ground, you take one wire and give the connection to the ground. Then if extra electrons are required, it can give. If no electrons required, it will not give. So now let us take one battery. this battery having, let us say 5 volt battery, this is positive terminal, negative terminal. Now if I connect this battery to this one, and always this is 5 volt terminal top side, and if I connect this to ground, then this is 0 volt terminal. That means I am ready to connect this 5 volts to this plate. Now if I take one wire and connect to this one, now this positive terminal attracts the electrons. This free electron start coming like this, and when this electron comes like this, current will go like this. So electron is coming like this. It can go to the ground, but it will not go because this positive ion attracts that electron. So that is why that electron comes and stays on this surface. Similarly this electron, then you say capacitor is charged. So conclusion, whenever you connect a voltage between two conductor surfaces, then automatically one surface positive charge comes, other surface negative charge comes. Now what Michael Faraday told, he told one statement regarding electric flux. He introduced the concept called electric flux. If this is the surface, then on this positive charge is there. Now 90 degrees to the surface, electric flux will start and go away and end on this surface again at 90 degrees. So he said electric flux psi starts on the positive charge and ends on the negative charge. Similarly like this, these electric flux lines go like this. And he told what is the total charge here. Let us say this is total charge is Q, let us say, on this. Now total how much electric flux goes away from this. So total electric flux here is equal to total charge, he said, because the electric flux, that means electric effect going away from this. Electric flux means electric effect only. How much electric effect goes away from this Q charge? Answer, whatever charge is there, that much electric effect goes away from this surface. So he said that the total electric flux leaving any surface is equal to total charge on the surface. That is the statement given by the Michael Faraday. And he did other experiments also. There are other statements. This is the statement of Michael Faraday regarding electric flux I am telling you. Now this is a parallel plate, and even if you take a cylindrical surface, so dear friends, this is parallel plate. Once again I am repeating, electric flux starts perpendicular to positive charge surface and goes away and ends at 90 degrees on the negative charge surface like this. So electric flux means moving effect of the electric charge. Then total how much electric flux goes away, then whatever amount of charge is there, that much. Because from electric charge only electric flux will be generated. Now if for example if you take this z axis, then now electric flux direction is here minus Az, and electric flux density also minus Az. What is electric flux density definition? I will tell you. If I imagine one area here, imagine bol raha hu, I am saying imagine, then how much electric flux crosses this area into normal unit vector to this area, or otherwise A psi cap. That means A cap means unit vector, A psi cap means a unit vector in the direction of electric flux, that is minus Az here. So that is called electric flux density. Electric flux by area into electric flux direction, that is Coulomb per meter square. Actually if you see here, electric flux and charge units are same. And also Michael Faraday said that both are equal because electric flux starts from electric charge only. This electric charge cannot move, but this is the moving effect of the electric charge. Example I will tell. There is a bulb, then bulb cannot move, but from the bulb light rays come out and they move. Like that only. This is a charge source, it cannot move, but from the charge source electric flux comes out that moves. So anyway dear friends, now if there is a a cylindrical surface on this positive charge is there like this, then automatically electric flux start perpendicular to this, and if there is any negative charge surface here like this, it is grounded external surface here, negative charge is there, then electric flux ends on the negative charge surface like that. Similarly, if I take here one solid sphere, so it is a solid conductor. I will write little bigger so that I will this one. So this is, let us say, r is equal to a radius. Then this is solid conductor sphere. Solid it is. Now it has only one surface. Here no, this non-moving charge. This is also non-moving charge, and here also if I put the here I have put a battery here, so that is why I got this type of charge configuration. This positive and this negative. So this is also solid conductor rod. This is, so this is non-moving charge. That non-moving charge stays, मतलब रुकता है on conductor surface only. So now this is called coaxial capacitor. This is called a parallel plate capacitor. Now we are going to talk of spherical capacitor. Capacitor means one positive charge surface is there, one negative charge surface is there. In between them, if air is there, that is called air capacitor. Then if dielectric is there, then that is called dielectric capacitor. Okay. Now there is one sphere. It is solid sphere. It is not a circle, student. It is sphere like this. Okay, like this. Now how many surfaces are there? Only one surface outside is there. Because inside it is solid, there is no surface. Why I am talking of conductor surface? Non-moving charge always stays on the conductor surface. Non-moving charge जो है वो conductor surface के ऊपर रहता है. Right. Now I may take here dielectric or otherwise any air medium. Any medium I will take. Dielectric means like wood material or otherwise any other material. Okay. Like plastic material, etc. You can put air also here. Then it is the air medium. Now here one more conductor surface I will take. It is hollow. Hollow means inside empty, and this is like a football surface. Now this is football means inside also empty, outside also empty, but the surface is of conductor surface. So this one is actually I am writing here. This is a hollow spherical conductor surface. Now let us say the radius of this is r is equal to b. Now here one conductor surface is there, only one conductor surface, because it is a one I am writing, one conductor surface, because inside it is a solid. Now it is like football surface means inside empty, so this is one conductor surface inside, and outside also one conductor surface is there. Total how many conductor surfaces? 3. Now if I take a battery here, then connect like this, plus minus 5 volt, let us say. Whenever I connect the battery, then automatically one terminal is it connected like this, it is grounded, and one terminal is connected here. Now this conductor surface has positive ions and electrons, positive ions and electrons, positive ions and electrons like this. So before connecting battery, this conductor is neutral, because any material is neutral, but this conductor has positive ion and negative electron, positive ion and negative free electron, positive ion and like that, negative free electron, so that it is neutral. Now, if I connect the battery here, okay, or 5 volt or 10 volt, whatever it might be, one terminal is grounded here. Now, this positive terminal attracts this electron and goes like this. It can go to ground, but it will not go because this positive ion attracts this electron. So this electron stays on this surface, inner surface. So ये जो इलेक्ट्रॉन इधर से क्यों आ रहा है, ये पॉजिटिव टर्मिनल अट्रैक्ट करता है, सो इसलिए ऐसा आ रहा है. फिर ये नेगेटिव टर्मिनल दूर भागा देता है, सो ऐसा आएगा इलेक्ट्रॉन. फिर ये जो सरफेस है इनर सरफेस के ऊपर रुक जाएगा क्योंकि ये अट्रैक्ट करता रहता है इसको. वो बोलता है दूर मत जाओ, इधर रहो, मैं अट्रैक्ट कर रहा हूँ आपको, बोलता रहता है, इसलिए वो ये सरफेस में रहता है. कैपेसिटर कॉन्सेप्ट, I told you parallel plate capacitor concept. Now in place of parallel plate, spherical surface is there. In parallel plate, charge stays on the parallel plate surface. Now here charge stays on the spherical surface. That much difference only. So similarly, if I take cylinder, then charge will be on the cylinder surface. That much very simple. Now similarly, this electron also comes, it goes here like this. And similarly, this electron comes and goes here like this. Similarly, this electron comes like this and goes here like this. Because electron can travel here also in the conductor, and it will take shortest path and then goes here. So in this way, what is happening here? Now because of this, let us say battery and the total here positive charge is accumulated, and let us assume total positive charge is actually, if you take it is a plus Q, here plus Q charge on the surface, total positive charge, then on this surface total charge will be minus Q. I am not saying this charge is plus Q and this is minus Q. No, I am saying this plus this plus this plus this, all total charge you add, no, positive charge you get plus Q. Similarly here negative, negative, negative you add, no, you get total charge is equal to minus Q. So in this way, here in a spherical capacitor, if dielectric is there here in between this conductor and this conductor, this is called dielectric spherical capacitor. And if air is there, then air spherical capacitor. Don't forget this. Again later on we will discuss these spherical capacitors. Okay. Now let us talk of surface densities, then we will go to the electric flux. Rho S I. Actually rho S means total charge divided by area. Total charge divided by area. You know. So area of the surface on which charge is present. Okay, this is the definition, students. Rho S means. Now rho Si means inner surface charge density. So that rho Si is equal to inner surface charge is how much? Q divided by what is the area of this inner surface? So 4 pi a square. So this is coulomb per meter square. If you want, actually what is happening here, if anybody gives total charge, then radius, then you can find rho Si. This is the formula. Similarly, if anybody gives an inner surface how much surface charge density is there, then multiply with the area, then you get total charge on this. So these two are formulas actually. So okay students, and here rho Si is uniform inner surface charge density. Uniform means constant, that is. Okay, so uniform inner surface charge density. Uniform means constant value. Actually no, why it is constant? On the surface charge is distributed uniformly. Uniformly means at every location same value of charge will be there. Okay. Similarly, if you want rho S O, rho S O, then minus q divided by 4 by b square. So rho S O, so rho S O is equal to outer surface charge is minus q. Actually, outer surface, inner side charge, that is, radius is b only, minus q divided by 4 pi b square. And if you want q, then minus rho S O into 4 pi b square. Actually, what is happening here? Charge magnitudes are same, but areas are different. That is why, if area is different, then automatically surface charge density value is going to be different. Anyway, this is just simple discussion. Now, what Michael Faraday said, if there is a spherical charge surface here, like this, no? Spherical surface, it is like this, spherical surface. Then on this charge is there positive charge, then electric flux line starts perpendicular to this positive charge surface and go away and end 90 degrees to the negative charge surface. That statement is given by Michael Faraday after doing experiment. So here he has given electric flux symbol as a psi. Like this will be going. Now, here dear students, like this. Here electric flux, he also told one statement, total electric flux going out of this charge is exactly equal to total charge on that surface, because the source of electric flux is charge only. So Michael Faraday gave the statement that total flux is equal to total charge. So here psi is total electric flux. The unit is coulomb. So here q is total charge from which psi is generated. Okay, that is also unit is coulomb only. Some students ask doubt in +2, no, they define psi as a q by epsilon naught. Oh, actually this is the perfect definition, not that one, because if you divide with epsilon naught, no, epsilon naught is 8.854 10 power minus 12, that is constant. Simply they are dividing with constant. Then what will happen? Units will change, nothing will happen. So this is the actual definition in engineering books. This is the perfect definition, because electric flux carries the effect of the electric charge, so that is why it should have the unit of electric charge only, so that is coulomb actually. So that is correct, dear students. Now anyway, here now we can define electric flux density also. So you know what is the electric flux density definition. So this is called electric flux, or otherwise displacement flux. Now what you do, actually, if you imagine I am saying imaginary surface, if you imagine one spherical surface of some radius r, let us say, what is this r? Actually general radius. So what is this surface? I am writing here imaginary spherical surface. So if you imagine a spherical surface of area 4 pi r square, so spherical surface of area, how much, dear students? 4 pi r square area, because it is spherical surface. Now, how much flux crosses this spherical surface, imaginary spherical surface? Answer psi, because whatever is generated this electric flux, that much crosses that spherical surface. So now electric flux density, or otherwise displacement flux density symbol D, because displacement no? D. Displace means moving from one place to other place, because this flux starts on positive charge, ends on negative charge. Okay, so displacement flux density D bar, or otherwise electric flux density, so is defined as, it is a definition, it is defined as D bar is equal to electric flux divided by area through which electric flux crosses, through which electric flux crosses, multiplied with you say electric flux direction. Okay, unit I have right now, that's why I'm seeing. So it is coulomb per meter square. So dear students, A cap means unit vector. You can write, I am not writing. A cap means unit vector. ASI cap means unit vector in the direction of electric flux. Okay. So for okay, this surface, no? How can I write? For the imaginary surface considered in case 1 at r radius d bar is equal to q divided by 4 pi r square. Q, how much electric flux is crossing this one? Psi. You can write psi also. Okay, psi divided by what is the area through which that is crossing? 4 pi r square area. What is the direction of this flux? Radially outward. That is AR cap. Now how much flux is going out? That flux is equal to Q only. 4 pi r square AR cap. Okay. So dear friends, can you tell me what is the electric field at r distance due to the Q charge? Answer: Q by 4 pi epsilon r square A. R square Q by 4 pi epsilon r square AR cap. That electric field is same as point charge only. Why? Because point charge also spherical surface. This also spherical surface. And on the point charge also total charge is Q. Here also total charge is Q only. But what is the difference? Point charge radius is taken from the origin. If point charge is at origin, here also radius is taken from the center of the solid sphere. So what is the d bar equation here? This is for A radius to B radius. Similarly, actually one formula is there. D is equal to epsilon E formula. From this, E is equal to d bar by epsilon. So that E bar is equal to, right there. Okay, E bar is equal to, okay, I will write that. So E bar is equal to that d bar is Q divided by 4 pi r square, and epsilon is divided this one for A less than or less than B radius. So this is the electric field equation in between these surfaces. So conclusion: electric flux direction is AR cap. Electric flux density direction also AR cap. Electric flux density direction and electric flux direction both are same. Now electric field direction also same, because d bar and e bar direction same. That is why I wrote at the beginning, if you recall, in note 1 point, I wrote in case of point charge, I wrote one note. What is that? Electric field lines and electric flux lines and electric flux density lines start perpendicular to the positive charge surface in outward direction and end on the negative charge surface at 90 degrees angle. So this is the electric field intensity equation in between the surfaces. Once again, this equation is valid between A radius, where is that? This one, A radius and B radius. And this radius is measured always from the center. You remember, in case of cylinders, in case of spheres, always radius is measured from the center. From whichever location charge is there, that means that the A radius charge is there. From that location only you can see the electric field value. So that is why A to B only electric field is there. Here I am briefing. I told you what is electric flux. That is moving effect of the electric charge. Then Michael Faraday said how much electric flux is released from any charge surface. The total electric flux is equal to total charge on that surface. Both units are same. Then electric flux density, or otherwise displacement flux density, definition is electric flux by area into electric flux direction. Now here one formula is there which gives the relation between the electric field intensity and the electric flux density. This is very important relation. In any case, if you know d bar equation, then you can find the electric field equation. Otherwise, if you know electric field equation, then you can find d bar equation. Till now, we know the electric field equation of point charge, like line charge, like surface charge. That means if you know electric field equation means you multiply with epsilon, then for all those cases you are you know electric flux density equation also. So dear students, if you know electric field equation, then multiply with epsilon, then you know your d bar equation. If you know d bar equation, divide with epsilon, you get the electric field equation. Now we will take one more case and we will discuss. Okay. So let us see the case 2. This is another case. This is also like Michael Faraday's experiment. Here there is one solid sphere. This one is solid sphere of radius r is equal to a. This is a solid conductor. Okay, this is solid conductor. I will write that conductor here. So this one is solid conductor. Now here one hollow conductor is there, and this hollow conductor of radius b is taken. Now here this conductor has positive ions and free electrons, so that it is neutral, because any conductor has positive conductor atoms. Positive conductor atom becomes then ion, so free electrons. It is neutral actually. Now you cut this here. After cutting, it becomes two halves, like this and like this. Okay. Now what is done here? This is also neutral. It is having positive ion, negative, like this, positive, negative. This is also neutral. That is also neutral. Now, woolen cloth का कपड़ा है. Woolen cloth is taken and rubbed on this surface like this. Then that cloth attracts electrons, and these electrons are gone away, so that only positive charge is there. Let us assume the total positive charge is plus Q here, plus Q. Now around this some dielectric medium is there. Dielectric medium is present, okay, of epsilon permittivity. Now here, where is the negative charge actually? That is on the woolen cloth that is kept aside. उसको बगल में रख दिया cloth को. So charge can be created and destroyed. There is a positive charge here on the woolen cloth. Negative charge is there. It is kept aside. उसको बगल में रख दिया. वो experiment में नहीं है अभी. Now these two halves are taken and kept here. So after that again they are joined here with the conductor like this. This is hollow conductor surface of radius B, but externally not grounded. So already it had a positive, negative like this, and positive, negative like this. Okay. Now, what happens? This positive charge attracts this electron. Now, this electron, this is conductor, no? Electrons can go from this side to this side, this side to this side, anywhere. So, this electron comes and stays on the innermost surface. So, this is the surface, conductor surface. This is inner surface, this is the outer surface. Because this positive repels this positive, so it is outside, it is an outside surface, positive ion. And that electron, actually charge stays on the conductor surface. Here inner surface, outer surface is there. It is not grounded here. So the positive ions are on outer surface because they are far away from this positive, because positive repel. Now negative charge is attracted by this positive, so negative charge is on inner surface, वो अंदर की तरफ फैलता है. So इस तरीके में ये जो नेगेटिव इलेक्ट्रॉन्स है अंदर सरफेस की तरफ आ जाता है क्योंकि ये अट्रैक्ट करते रहता है नेगेटिव. कंक्लूजन इज दैट, कंक्लूजन क्या है इसमें? ये क्वेश्चन है, दिस इज वन क्वेश्चन. If there is positive charge on the, if there is positive charge on the inner surface, then after some time, if we get the conductor surface, then what will happen? Answer is, there is a positive charge having Q charge. Then if you get the conductor surface, then answer is on inner surface minus Q charge total. Here, total minus Q charge. Again on outer surface plus Q charge is formed. That is the answer. Once again, I am asking question. If there is a solid sphere, on that if plus Q charge is there, then after some time we get one more conductor surface which is not grounded, then what will happen? Answer, on the conductor surface, on inner surface minus Q charge and outer surface plus Q charge is formed. That is the answer. Now, in this question, if you see electric flux lines start here on positive charge and end on negative charge. Similarly here, like this. Again, they start here and keep going away until they find a negative charge. So, here electric field equation also present. Here also you can write electric field equation. What is the electric field equation in between the conductors? Answer, electric field here, for example, electric field at this location is generated due to the Q charge. So answer is Q divided by 4 pi epsilon r square AR cap. So here radius is measured from this location. If you want electric field at r radius, then that radius is measured from here. Okay. So this is r is equal to a radius. R is equal to a radius. At R radius, this R is variable. Electric field is this one, because electric field is generated from Q charge only here. If you have doubt now, you take here Gauss surface. Inside that Gauss surface, Q charge is there. So whatever charge is there inside Gauss surface, because of that charge only electric field is generated here. That is Q charge. Then what is the role of this? Electric field starts here and ends here. So this is a source and this is sink. Once again, how much charge is there total outside? Q charge. Then again electric field generates here, and because of Q charge, then Q divided by 4 pi epsilon R square here. Again electric field equation is same. So conclusion is, in this case, electric field equation is equal to Q by 4 pi epsilon R square AR for A less than or less than B, and also electric field is equal to Q divided by 4 pi epsilon R square AR for B less than or less than infinity, and electric field is 0 for 0 less than or less than A. So electric field is 0, because inside this sphere there is no charge, so electric field is 0, because non-moving charge always stays on the conductor surface. So electric field 0 for 0 to A radius. Between A and B radius, electric field is this one. But you may ask question, here also electric field equation, here also electric field equation is same, then what is the difference? Why same? Because here electric field is generated from Q charge, here also electric field is generated from Q charge, that is why electric field equation is same. Now then what is the difference? Answer, here radius means measured from center to this location. Here radius means measured from center to this location. So here radius is more, here radius is less, that much only difference. That is why here R is for this one, R is from B to infinity. Here R is between A and B. So based on this concept, one question is there, we can solve that this concept. Question number 45. So GATE students, this is question number 39. Actually, question is like this. The electric field strength at a distant point P due to a point charge Q located at the origin is saying that point charge is there, Q. Then electric field at point P, electric field at point P, that means distant point means it is at some distance. Electric field is equal to 100 microvolt per meter. Now, first I am asking question. This 100 microvolt per meter electric field is generated due to which source? Answer, due to Q charge source. That is the answer. Okay, if you know that thing, now let us go ahead with question. Full stop. So once again I am reading, the electric field strength at distant point P due to a point charge Q located at the origin is this much. Now full stop is there. After that I am reading, if the point charge is now enclosed by a perfectly conducting metal sheet sphere whose center is at the origin, then the electric field strength at that point P outside the sphere becomes. Actually, now again same thing I am writing, student. This much now. So Q charge. So in the same question, here is the P. Now what that person is saying, if the point charge is enclosed means around this point charge there is one metal surface, metal spherical surface is there. Around this means that is spherical surface only. So this charge is enclosed by this one. That means inside the surface, this charge is there. Now question is, what is the electric field again at same location? That is the question. That's what we were discussing now. If Q charge is there, like this Q charge is there, then if we get the conductor surface here, then inside minus Q, outside plus Q charge is generated. That means once again, here on this conductor surface, positive ions and free electrons, are present before putting this charge. Now, what do you say? This positive charge pulls this electron, comes here, pulls this electron, comes here, pulls this electron. ये भी pull करेगा उसको. So conclusion is here total charge is minus Q, and again here total charge is plus Q. Now dear students, here electric field, this is the one. Here electric field equation inside and outside same. Now here electric field equation, same. Now because of this charge, distance is same. See how much charge is produced electric field here, Q charge. The distance is from here to here, let us say some r dash distance. So now also here total charge is Q, but distance always measured from the center, I told you. From distance from here to here is same. So once again electric field is same. So that is 100 microvolt per meter. Some students may confuse that, sir, distance come again. No, actually total charge is not at this location, that is distributed. That effect is reduced. Anyway, don't worry, I told you. Electric field here, equations are same. Because here also electric field is generated due to Q charge, here also electric field is generated due to Q charge. Distances are always measured from center. So now electric field equation here also same as the electric field here due to this small Q charge 4 pi epsilon r square ar. So here r means distance from center to this location. Here also electric field equation due to point charge is Q divided by 4 pi epsilon r square ar. Here also distance r means distance from center to this location, same. So same electric field. So for this question, option is B. Which option it is? Yes, option B it is. Same. Electric field. Electric field is same. Okay. So you remember this. If there is a Q charge anywhere, positive charge, around that if you put one conductor surface, then automatically on inner surface minus Q outer surface plus Q charge is formed. Another question I am asking. If there is this is for your general knowledge, if there is a Q charge, then if you put a metal surface, this is another question, student, for your knowledge. If you put a metal surface, then what will happen? Answer here, minus Q charge is formed. Okay. And here positive ions will be there. And those positive ions will have total how much charge plus Q charge, that you know already. Now question is like this. If there is a Q charge, around the Q charge, grounded metal surface is kept, then what will happen? Answer I told you now. This ground can supply the electrons. Now this positive attract this negative, and they are in the interacting process. Now this positive also attracts electrons from ground, so electron comes and stay here. Now this become neutral, and similarly electron comes here, that becomes neutral, no need to show charge. So all become neutral. So conclusion is that if you put grounded, anyway students, if you put grounded surface, no, the charge will not be there. So no charge will be there. So You see this one also, this one also. Okay. Now we will write one note on the electric flux. Okay.